All right, so we're going to do some practice problems. And this is similar to what I just did. So what this is saying is the limit as x approaches a of the given function. Okay, so I'm going to use the graph. So what are our options? We can use direct substitution. Well, I don't know what the equation is, so I can't use direct substitution. I can use direct substitution or algebra. Well, I'm stuck. I can't use a table of values because I don't have an equation to use. And so my last option is go ahead and tell me using the graph what's going on. So as x approaches a, where a is 1, so this is my particular x value that I'm creeping up to. Tell me what the limit is. So as I come at it following the function, as I come at it from the left, what y value am I creeping up to? I'm creeping up to a 2. As I come at it from the right, what y value am I creeping up to? I'm creeping up to a 2. So then the final question is, does the 2 from the left equal the 2 from the right? Does 2 equal 2? Yes. Then your limit is 2. Okay, so it's pretty basic and straightforward. All right, so same thing. I have got the graph, and I would like to determine the limit as x approaches a. Well, in this case, a is 1. So here is my a of 1. This goes this way. Sorry, that was lovely. With an open circle. And this goes up to here with a closed circle. And I'm trying to find out if, if this is my target where my x value is 1. Okay, so I'm going to come at it from the left. So following my function and getting closer to an x value of 1. So from the left, when I creep up, it looks like I'm creeping up to about a 1. I don't know, I kind of drew over it, so I'm not sure. Okay, as I come at it from the right, I'm coming and creeping up to a 3. So from the right, I'm creeping up to 3. From the left, I'm creeping up to 1. So does 1 equal 3? No, it doesn't. So in this case, the limit does not exist. So what you have, so go back and remember what we're doing here. What you're doing is you're telling me the y coordinate that you are approaching as you sneak up to an x coordinate of 1. You're not creeping up to the same y coordinate from the left and the right, so your limit can't exist. Okay? So there's a couple options. So those are graphs, so I'm going to skip the rest of the graphs. So there's a graph. All right, so let's do a table. So we have a table this time. Now, we are lazy math people. So what this says is complete the table by computing your function at the given values of x, run your answers to 3 decimal places. So we're going to do that. But what this says is find the limit as x approaches 5 of your given function. So what I could write out is the limit as x approaches 5 of 2x squared minus 5. Okay, well, can I use direct substitution? So pretend like the table wasn't there. Can I use direct substitution? There's no reason why I can't. Nothing's going to be undefined. Nothing's going to be weird. So use direct substitution. So if I shove in a 5, 2 times 5 squared is going to be 2 times 25 is 50. 50 minus 5 is 45. So I already know the answer to this. The issue is I've got to creep at it from the left and from the right. So we want to sort of show you empirically, meaning observe and see what I do. Okay, observe this empirically. So if I'm creeping up to 5, do you agree that 4.9 is pretty dang close to 5? Yeah, it is. But 4.99 is closer, and 4.9999 is closer, and I could get even closer to that. So this is my target of an x value of 5. Well, then I can come at it from the right. So 5.1 is a little bit further away, but 5.01 is closer. 5.001 is pretty dang close. So I'm going to use the table feature on my calculator. So the way I do this is I am going to hit y equals, okay, on my, ooh, look at that, pretty. All right, so I'm going to hit y equals, and I'm going to enter my function. So I've got a 2x squared, so 2x squared, and then, what is it, minus 5. Okay, once I do that, and this is the important part, you need to make your table set right here. So I'm going to hit second because I'm trying to get to the blue stuff. So second window will take me to table set. And you want this to be set to ask. So in my case, it already is. So highlight it, hit enter, and now it's ready to go. What this is going to do is it's going to say, instead of it figuring out the X values on its own, it's going to ask you for them. So you're going to tell it the X values. So now hit second graph, and that's going to take you to the table. So second graph, and now I got stuff already in here, so I'm just going to clear this. Well, that didn't work. All right, so it doesn't matter. I'm just going to start entering this stuff in. And what did we already say? Look, it's there. If I shove in a 5, what's going to pop out is a 45. Well, I'm not supposed to know that yet. So I'm going to hit 4.9 and let it figure it out. Hit 4.99, 4.999, and then I'm going to hop on over to the other side and do 5.001, 5.01, and 5.1. Okay, so what do I get? Sorry, not, all right, whatever, it doesn't matter. All right, I'm tired. All right, so when I have 4.9, when I enter into 4.9, I get 4.302. Okay, if I want to highlight it, I can see if it actually has further decimal places because your instructions are 3 decimal places. Okay, so this is a 4302. So I've got 4302. This one, I'm going to drop down, and it's 4.8. Well, down here I see that it's 44.800. So I've got 44.800, and I should put a 0 on the end of there. Okay, drop down further. Now, what Y value are you creeping up to? I was at 43, now I'm at 44. I'm pretty dang close to 45. So this is going to be 44.980. So 44.980. Now hop on over to the other side of 5, okay? And I'm going to get 45.020. So 45.020. Drop it down here, and I get 45.200. So 45.200. And then finally, I get 47.02. So 47.020. And so now what we've done is we've used a table. So what did we say before? Tables are tedious. I don't want to use a table unless I absolutely have to. But you're showing me algebraically you're creeping closer from the left and you're creeping closer from the right. And then if you look at these two, you are hovering right at 45. Okay? But did direct substitution work? Yes, it did. So my answer is 45. Okay? On this one, I'm going to show you how to enter it. Oh, look, it's already the same numbers. Just in case you don't know. So go back to y equals. What you want to do is use the absolute value function. Okay? So if I use the absolute value function, I'm going to hit math, which is here. And then I'm going to scroll over to numbers. And number 1 is absolute value. So I've got the absolute value of x minus 5. And I want that to be over. And you want to put x minus 5 in parentheses. If you don't, it's just going to do the absolute value of x minus 5 over x. And then it will subtract 5 off of that answer. So do x minus 5. So now I've got a numerator in grouping symbols over a denominator in grouping symbols. So now when I do that, look at this miracle. So what you have is negative 1s all from the left and positive 1s all from the right. So what's your limit? So I want to show you this particular one if I use direct substitution. So this is going to be an issue when we use direct substitution. If I shove in a 5, that means I've got the absolute value of 5 minus 5 over 5 minus 5. Well, what's 5 minus 5? It's 0 over 0. So this is a moment for congratulations because you have never, ever, ever seen this format before. You've always seen 0 over any other number, or you've seen any other number over 0. But you have never divided by 0 into 0. You've never done 0 divided by 0 until this very moment in time. So, woohoo! This is actually a Calc 2 problem, okay? It's called an indeterminate form. So, indeterminate form. And all it means is I don't have enough information. It's an indeterminate form. I don't have enough information to draw a conclusion. So in that case, I would have to go to the graph or I would have to go to the table. So when you looked at it from the left and from the right, well, from the left, stop it. From the left, I was approaching -1. From the right, I was approaching +1. So does -1 equal +1? No, it does not, which means your limit does not exist. Okay, so you're still going to fill that thing in. So you can do this one. Okay, you can do number 7. Let's look at number 8. Excuse me. All right, so what I have is the limit as x approaches 8 of 4. So remember, 4 represents your function. So I could say f of x equals 4, or I could say y equals 4. So what it's asking is, as I creep closer to an x value of 8, what y value do I creep closer to? Well, it doesn't matter because all of my y's are 4. So if we go to here and just say, please graph 4, okay, well, you'll notice when I graph it, if my target is 8, so I've got 8 over here, well, what y value am I creeping up to from the left? It's 4. And what y value am I creeping up to from the right? It's 4. Does 4 equal 4? Yes. Then your limit exists. So this is one of those tricky things. There's really nothing to do direct substitution with because there's no x variable in my equation. Okay, so on this one, my answer is just 4. And you can do that direct substitution or otherwise, which means you can now do number 9. Ooh, let's do number 10. All right, so if I have the limit of x, so remember, that means that my function would just be x, or y equals x. Is anything keeping you from doing direct substitution? So in other words, wherever there's an x, put a 6. So that means I just tried to cross that out. This is now 6. Okay, this is just a diagonal line that slices through 0 and has a slope of 1. So as I creep up to an x value of 6, that means the y value that I creep up to is also 6. Okay? So you can do 11, you can do 12, you can do 13, you can do 14, because you can do direct substitution on every single one of these things. This should be in parentheses. That's irritating. Okay, because you're taking the limit of the whole thing. So you can do